On this slide, I would like to provide an alternate method to Kirchhoff's law for the determination of standard reaction enthalpies at temperatures other than 298 Kelvin. This method will be of great use in subsequent chapters and makes it totally unnecessary for you to memorize yet another equation. So let us consider again the reaction between glutamate and ammonium to produce glutamine and water. Let's assume we are interested in the value of the standard reaction enthalpy at some temperature T other than 298 Kelvin, and that we know the value of the standard reaction enthalpy at 298 Kelvin, as well as the molar heat capacities at constant pressure for reactants and products. Since we know the value of delta RH standard at 298 Kelvin, let us write the thermochemical reaction equation at that temperature for that standard pressure. On this schematic, you can now see four states: reactants at P standard and T, reactants at P standard and 298 Kelvin, products at P standard and 298 Kelvin, products at P standard and T. To calculate delta RH standard at temperature T, we can either follow the single arrow between reactants and products at P standard and temperature T, or we can follow the arrows marked as 1, 2, and 3, which makes use in step 2 of the reaction at 298 Kelvin and standard pressure. Using Hess's law, the value of delta RH standard at temperature T is equal to the sum of the delta H for step 1, 2, and 3. Delta H for step 2 is obviously the delta RH standard at 298 Kelvin. Delta H for step 1 corresponds to the change in enthalpy associated with the isobaric heating or cooling of reactants between temperature T and 298 Kelvin, while the delta H for step 3 corresponds to the change in enthalpy associated with the isobaric cooling or heating of products between 298 Kelvin and temperature T. Stages 1 and 3 are isobaric because reactants and products are always under standard condition, P equals P standard. In view of the above, we can write delta H for stage 1 as the sum of the CPM times 298.15 minus T for both glutamate and ammonium, and the delta H for step 3 as the sum of the CPM times T minus 298.15 for both glutamine and water. This allows us to write the expression for the standard reaction enthalpy at temperature T in terms of the standard enthalpy at 298.15 Kelvin, in terms of the molar heat capacities of reactants and product, and in terms of the temperature difference. Rearranging these terms leads to the form of the equation given by the Kirchhoff's law.